Hello everyone, this is Poornima Deepthi working as an assistant professor in the Department of ECE at MLR Institute of Technology. So today's presentation is the instruction set of 8051 microcontroller. In this one particularly bit manipulation and branching instructions. So this video is a part of series microprocessors and microcontrollers. Coming to the overview of today's presentation, how many types of instruction sets are there in 8051 and today's topic bit manipulation instructions and branching instructions. So clear, set bit, these two are the bit manipulation instructions, and carry jump if carry is there, jump if no carry, jump below, jump if not below, jump. So these are the branching instructions. So coming to the instruction set of 8051 microcontroller. So based on the operation it performs, the microcontroller has been divided into 5 types. So data transfer instructions, arithmetic instructions, logical instructions, bit manipulation instructions, and branching instructions. So today we're gonna learn about the bit manipulation and branching instructions of 8051 microcontroller. So coming to the bit manipulation instructions, this bit manipulation instructions deals with the direct bit addressable areas in the RAM and some of the SFRs also. So special function registers like in timer register we can use this bit manipulation instruction. In PSW program status word we can use this bit manipulation instruction. So like that we can set the each single bit in the position, or you can set or reset the bits using bit manipulation instruction. So these are the some of the examples of bit manipulation instruction. CLR, clear carry. If any carry is there after performing any operation, if carry bit is set, but the next application doesn't require the carry, so in that position we can clear the carry bit. Or in specific function, like if we want to reset all the bit positions in PSW program status word to select the bank register banks, bank 0, bank 1. So if we want to select the register bank 0, so we need to keep PSW 3 and PSW 4 as 0, 0. So we doesn't know whether it has been 0, 0 or anything. So if we want to select this bank 0, it's better to clear this. So how to write clear instruction? So let's if we want to clear PSW 3, I want to set PSW as a 0. So you can write CLR PSW dot 3. So this bit position in the program status word will be cleared and it will have the value 0 over there. So like this you can instantly change, or you can set also. Set if I want to select bank 1. So what is how to select bank 1? So we need to keep these two as 0 and 1. PSW 4 should be 0 and PSW 3 should be 1. So in this position, I need to keep PSW 3 as 1. But just now only I have cleared PSW 3. So it will be 0. Now how to set that particular PSW 3 as 1? So you can use the instruction set bit. So you need to set bit PSW dot 3. It will go to the PSW program status word and that particular third bit, it will set it as 1. So to set the 1, you use set bit. To reset or to clear the data which is present in that particular single bit addressable positions, you can use clear. So here set bit carry. If carry is there, you can use by using the C. So here set bit position, like here I have mentioned PSW3 like that. So CPL, you can manipulate, you can perform complement operation over carry. So complement, if carry is 0, after performing this complement operation, CPL is complement carry or performing not operation. So if carry is 0, it will perform 1. If carry is 1, it will give 0. Likewise, you can alter the CPL bits. Suppose here if I want CPL PSW dot 3. If PSW dot 3 is 1 before, now after performing this complement operation, it will toggle between the bits. If 1 is there, it will toggle to 0. If 0 is there, it will toggle to 1. So like that you can perform AND operation, OR operation, XOR operation between each addressable bits. See here ANL operation, as you already know that in previous video I have already discussed the logical operations of 8051 microcontroller. So in that one I have already explained the AND operation, OR operation, rotate operation, shift operations, everything. So here it will perform AND operation between the carry bit and the bit you have mentioned. Suppose I can write the operation as ANL carry comma PSW3. So it will perform AND operation between the carry bit. If carry is 0 and PSW is 1, the output is 0 because AND operation. So if the both inputs are high, then only the output will be high, like that. So here also. So now or it can perform OR operation, right? So coming to the next one here, clear CLRC. So if carry is 0, to set the carry 0, we can use 0, or else you can directly mention the address of the memory which you need to clear. Suppose CLR30H, so it definitely specifies one address of the memory, direct address. So in that particular direct address, it will clear the data. So direct address, as I have explained in the internal RAM organization structure, so the internal 128 bytes of memory has been have every address location for each and every byte of the memory. So you can use that internal memory to directly specify the address over here. So next one is set. I have already told you that you can set carry bit or you can set bit. So now here set bit 30H. So it is a address. So it will set 30H memory location as a 1, right? Yes, you can use complement operation, complement carry you can use, or else you can use the complement direct location. In that direct location, it will toggle the bits, right? Move bit carry. So here move C comma 30H. So here the data present in 30H bit will be moved to C carry register. So vice versa also done in this bit manipulation instructions. So coming to the next set of instructions, these are you can use as a jump if carry, or these are branching instructions, as well as here you can use bit manipulation instructions also. How? So see here jump if carry is there, it will jump. So JC means carry to real address location. So jump if carry is there, it will jump to the address location which we have specified. Here it is jump if no carry is there. If carry is 0, then only it will activate. So these are some type of branching instructions. Jump if bit is set. So JB, jump if bit is set. So if the specified bit is set, then only it will jump to the location we have mentioned there. If JNB, if bit is not set, so in that particular location where we have mentioned the bit, if that bit is 0, then only the operation will be performed. Here next one is JBC. Jump if bit is set and clear bit. It will perform if the bit is 1, then it will jump, and after jumping it will clear that particular bit. Suppose I have write JBC PSW.3 comma 30H location, right? So it is JBC, jump if bit is there. So it will check if PSW3.3 is present. Yes, if PSW.3 is 1, then bit is set. So it will jump to the location. The execution of the controller will move to the location 30H. But the thing is here, it will clear PSW to 0. That is this instruction. So this is the some of the examples of JC. Jump if carry is there, jump if no carry is there. See here set bit carry. So after performing this instruction, the carry bit is 1, right? We have set the carry. Now JC here is a loop. So here it is a loop. So JC subprogram, you can say it's a subprogram heading also. JC jump if carry. So it will check the carry bit. Yes, in the previous instruction we have already set the carry. So jump if carry is there. So yes, it satisfies the condition. So where it will move? It will move to the execution of the controller will move to the here. So here what I have written, increment A. A will be incremented with +1 operation. Right? So let's see. After that I have cleared C. Right? Clear C is there. So here clear C means C will carry will get into 0. So now J and C, jump if no carry is there. Yes, jump if no carry. Yes, carry is not there because carry is 0. So it will again move to the increment operation. So if after increment A, if I write return, then only it will move back to the location. If not, it will stay here only. Right? Yeah. So coming to the JB and JNB instructions. Jump if bit is there, jump if no bit is there. Let us see. So here set bit 30H. So the memory location 30H is having the bit 1. We have set. So jump here JB. Jump if bit is there. Yes, we have already said. So where it will need to move? It need to move to the location skip 1. So here it is the skip 1. Now move A, 55H. So here we represented hash. So it is a raw data. After this A will become 55H. Now CPL P1 not dot 0. So here CPL. CPL means complement. What P1 dot 0? P1 dot 0. Complement P1 dot 0. P1 dot 0 means in port 1, 0th location. So we have 4 ports. In the previous video I have explained. So 4 ports, you can use these 4 ports as input and output ports, and some ports have special application also. So here complement, if the P1 dot 0 is 0, it will become 1. If it is 1, it will become 0. So toggle will be there. Clear 30H. So the location 30H will be cleared. So now 30H location is having 0. Now what it wrote? J and B. Jump if not bit is set. So which bit? You need to check. 30H. So yes, 30H bit is 0. So condition satisfies and we need to move to the skip to location. What is skip to? Here. So here move A, 0 AAH. As I already mentioned, in hexadecimal number we will represent A to F alphabets. But while you are giving the immediate data or raw data, you shouldn't give the characters directly. So you need to mention the characters. If the first one is the character, then you need to mention 0 before that. That's why I have mentioned 0 here. So after execution of this this instruction, A will become AAH. Accumulator is AAH. Now complement P1 dot 1. So in the previous video, in the previous instruction over here, if the bit is 1, now it will become 0. Toggle. Yes, complement means toggle condition. Now what they have written? S jump done. So S jump is another branching instruction. So S jump means short jump. Short jump done. So we need to jump to the location done over here. So this will be end of. This will be the ideal one. It will repeat until the program runs. So here is the end. So these are the bit manipulation instructions in 8051 microcontroller. Coming to the next instruction, JBC. Jump if bit is set, then clear the bit. Suppose let us consider this example of this program. So here in set bit 30H. So here 30H is the address location, right? So if this is the memory location, and it is having 30H, 31H, and some location is having so 41, 42, 43, 44 locations of address, right? So if this memory is like that, now set bit 30H. So in this particular one, it will set the bit as 1. So now here JBC, what is the operation of JBC? Jump if bit is there, and after performing the jump operation, it will clear that particular bit, right? Yes. Here JBC 30H comma skip. So here 30H is the bit position and skip is the location that a controller needs to perform the execution if it satisfies the condition over there. So here JBC, jump if bit is there, bit is set. So yes, in the previous instruction we have already set the bit. So in 30H, so it will check, yes, bit is there, it will satisfy the condition and it will jump to the location skip. Here skip is there, right? So it will jump. Now what the controller will do? The controller will clear that particular bit. So here we have written this particular bit 30H. So this bit is toggled or cleared. So it will become 0. In this particular position, it will become 0. Now a cursor moves to this location. So here what we have written, move a comma 40H. So again 40H is the location of the memory. So here if 40H is holding some data like 72, 91, like that, right? 41. So memory, it will have some data, right? Yeah. So 40H location, what is the data? In 40H, 72 is there. It will load into the A equals to 42, right? Yes. Next one is add. It will perform add. How this instruction will perform? A is A plus the data present in 41H location, right? Yes. Here the accumulator A. What is the data present in A? 42. And what is the data present in 41H location? So 41 is this and the data is 91. It will perform the hexadecimal addition operation. So what is the output? 2 plus 1, 3 and 9 plus 4 is 13. But how we will represent 13 in hexadecimal number? So D is represented as 13, right? So the output is D3. Yes, the accumulator will hold the output D3 as I already told you that destination register or destination operand will hold the data, right? Yes, what is the destination source here? Accumulator. So accumulator will hold D3. So in this next instruction, move 42H comma A. Whatever the data present in this accumulator will be moved to the location 42H. Now see, 42H is already having the data 41H, but it will be reloaded with the data D3. Okay, this is how we will reuse the memory. So after that, move A comma 0, 0. We are clearing the accumulator as 0, 0. Add C. Add C. So what is the exact operation of add C? So add with carry. So here A. We need to add A, the data on the accumulator with 0, 0, H. So A will become, the data in A is already 0, 0 and data here we need to add the mention as 0, 0. But the thing here is we need to use add arithmetic addition using carry. So if carry is 0, then the output will be 0. If the carry is 1, we need to add carry to this particular arithmetic operation because we have mentioned add with carry over here. So it will become 1. Okay, it totally depends upon the carry. Right. Next one, move C comma ACC dot 0, accumulator ACC dot 0. So here that particular bit position, the particular bit we have mentioning here will be loaded to the C. Okay. Now move P 2.0 comma C. So P 2.0 here is in port 2 0th location. So as I already told you, we are having port 3, port 1 and port 0. So we are having 4 ports which is having 8 input output lines. We can use these 4 ports. Out of 4 ports, 32 output lines is there. We can use these 32 output lines as inputs or outputs, depends upon the application we've been using, right? Yes. If suppose it's okay, now again I need to run this program. So here, if in previous one, the bit is 0, right? So if this instruction is not there, so now JBC, jump if bit is there. So here we need to check 30H location. If 30H location is having 0, the condition doesn't satisfy over there, right? So if the condition doesn't satisfy, the controller need to execute the next instruction itself. So this instruction will not be executed. The controller will not will not go to the location skip because the condition doesn't satisfy there, right? Now the next instruction will be executed. So what is the next instruction? S jump. S jump means short jump. So within the range, if it is having the within the range 4 or 5 instructions less, so then it will move to that consider as a short jump. So here short jump, fall here. So it will again repeat that instruction itself, right? So until now we have discussed the bit manipulation instructions and the bit manipulation instructions using branching instructions. So thank you.